This is a tuning indicator, or otherwise known as a magic eye. It was a thing that was fitted to a lot of radio sets and receivers to aid tuning them in. This is long before moving coil meters became cheap enough to put meters in instead of these essentially things that work like a cathode ray tube. As so far, I've done a video on the vacuum fluorescent tube. I've also done a video on the Nixie tube, but it seemed only right that we now do a video on the magic eye. This old device here was something used before meters became commonplace. It works on an interesting principle. This is essentially a valve. Anybody who recognises it knows a bit about valves. This could well be a triode over this side. And it's actually, there are two parts of it. There's the part which we actually view, which is the target right at the end. And then halfway down, you see there's another portion, and that is actually the triode. And how it works, quite simply, is we put a high voltage on the target. We put fluorescent material on it, and that's what you can see at the end, which is this particular piece round here. It could also be, he's looking for another one, it also could be a surface like that if you view from the side. And what happens is this will obviously glow, but in between there is this little bar put in, which is like something to put an interference in, stopping the electrons going through properly. And when the triode is not conducting, in other words, the grid is completely taken negative, then the triode anode and this interfering little piece here sit at about the same potential as the target, and therefore all the electrons will go through to it and the whole thing will glow properly. But as you gradually increase the voltage on the grid, you'll find obviously the triode starts to conduct, this starts going negative, and then you start seeing an effect on the screen where, on the target where it seems to be coming apart, because it's obviously avoiding this area here which has the negative potential on it. There are several different sorts of these valves built. They all look very, very similar in many ways. Some come in at the end, as you can see here. Then obviously, as the one I showed you, just the EM81, you just have a side view, and this would have been used in a smaller piece of equipment. There are other sorts as well, very small ones with little exclamation points, but they all work on a very similar principle. They're not all exactly the same. Some have extra electrodes in them, but this is a good start on what they actually work like. This particular example is very good at actually showing us all the bits we were talking about. If you look, this saucer shaped bit is the target, which you viewed from the end. The two pieces of wire going up either side, they have the positive voltage for the anode, and that sits connected to that. In the middle you can see the cathode. This cathode runs through the triode. This is the triode piece here, and here you can see this little piece I call the interference piece, which runs up through here, and that is the one which actually is connected also to the triode's anode, and that's why the display here will be interfered with by this, and you have the effect you've just seen on the circular display in the R1155 receiver. Here we see a very good example of a tube that is not too worn out, hence we have the light on. This is another one which is very similar to the one inside the R1155 receiver. I have two PP3 batteries down here. In here, this is simply connected to the grid of the triode, and it's obviously floating at the moment. If I touch it on the chassis, there's a small change to the direction it's going outwards. And these are the two batteries. If we look at this, this gives you a -9, so that's just using one battery. You see how much it closes. And if we go to -18, significantly more. A point to note about these things is buying these second hand, the odds are that they could be as dim as this one. You note how I've turned all the lighting out so you can actually see it. Another point of interest is the fact that I've noticed this is the universal chassis we use, and it has 95 volt HT. I tried running one of these with the 95 volts and it just does not work, even the good one. So it's worth bearing in mind if you're going to build a circuit using one of these, make sure you have a good one, and that you probably need 250 volts, because it's 250 specified in most of the sheets I've seen for all the ones we have here. So you can't get by just throwing 100 volts at it, because the display, only half the display comes out. I tried it with several of them, none of them work properly at that level. Anyway, hope this is of interest to someone. Thanks for watching.